So Douglas works at NAQTS, which is it's an actual company rather than a EU project, but also looking at developing methodologies for doing particle analysis. And one thing I want to say about these, I've just seen pictures and actually seen them on the desk. They're really quite nice and small, transportable. Which I'm wondering if that's something you're going to go and sell. But have you actually got your PhD yet? Or are you still?
That's my bit of fun on the side.
You're still doing on the side. So you are actually a Lancaster PhD student, along with running a company. So all of you just graduated with PhDs and not been running a company, you're not been working hard enough. Sorry, Lucas. Thank you very much.
Well, thank you for the opportunity to talk today. I think Neil brought up a good point earlier, which is, no, we're not the only people developing devices to know particles. I wish we were, that'd be very good for business for us. But what we're trying to do, fundamentally, is increase awareness of nanomaterials, ultrafine particles, as part of a holistic device to measure air quality, principally indoor air quality. So what I'm going to talk about today is integration of some of these regulatory techniques for measuring ultrafine particles alongside a host of low-cost sensors, which bring, as you'll see, challenges and opportunities. So first off, a bit about who we are. Originally based down south, we moved up to Lancaster to co-locate in the Environment Centre. It's a very good hub for small business to improve their technologies and access some of the talented research staff. As I said, what we're trying to do is incorporate lots of different analytical techniques into one plug-in-the-wall, turn-on device, which can measure all of these things with accurate results. Based in 3 locations, Lancaster, US, and recently China, which has been exciting for us. So what we're doing at Lancaster? Well, first off, we sponsored 3 PhDs, one of them being my own, which obviously is going to be my favourite, which is this last one. Looking at the relationship between indoor air quality, where we spend 90% of our time, and environmental justice. So this is looking at, are certain populations more likely to be exposed to higher levels? So it's looking into concepts such as polluter pays and other things. Also looking at energy efficiency and indoor air quality again. This is looking at the dichotomy between keeping our homes warm and reducing our carbon footprint, but at the same time ventilating enough to get fresh air inside buildings. In new builds, they're often built to be airtight, so that a lot of heat stays within the building, but if there's a significant source of pollution inside, it can become trapped. And the third project, this particular matter mitigation, is looking at HEPA filter filtration indoors in Guangzhou in China. So this is the core, this is the heart of our device, our air quality bench. About yay big. This goes into our integrated unit, but we also sell this as an OEM device. And we're measuring a lot of different things. So first off, we're measuring particle number with a full mixing CPC. That's a condensation particle counter. So we're taking these particles as low as 15 nanometers, like how a cloud works, using them as a nucleation site, condensing them onto a solvent, passing the particle later. Really simple piece of technology, been around for about 30 years. What's happened is they've got smaller, easier to operate, and use less working fluid. So with this device, we host a lot of other different sensors. These low-cost sensors, electrochemical and metal oxide, are very exciting, but also give me a headache. So you can buy them for about £20, very, very small, powerful devices. But you have a sensor that says it measures CO, it's actually measuring 20 other things at the same time, and you can't always differentiate what it's measuring. I'll go into this a bit later on these sensors. Also measuring volatile organics with a metal oxide sensor for TVOCs, but as well with thermal absorption tubes and lots of other applications. So this goes into the heart of our box. As Neil said, about this big. Effectively, it's a portable air quality monitoring station with regulatory grade measurement for ultrafine particles and everything else you've seen. Really, I should have brought one over, that would have been nice.
Well, most people here are, a lot of people here are your last people or Lancaster University based, and we have our project team who can, I think you've been talking with Carlos quite a bit over various things, you might see them, but just quick, NAQTS are on the second floor, almost opposite our IT teams. It's just slightly down there and Jonathan's office, but on the opposite side of the corridor. So
the Yordas building.
The Yordas building, yes. And only you get to take over a more of it. All the way up there.
Have the next slide, please. So this is just an example of the real-time GUI setup we have for interacting with the equipment. What we're trying to do is make it easy to be able to set up a test and gather data. We use this for hosts of different things. This, for example, is looking at the air quality inside vehicles, which has been an increasingly exciting area for us to measure. You can imagine some of the sources of pollutants that come around that other vehicles are very close by. So you can have a measurement device, but without the actual metrology data, just a magic black box. So this is our accreditation from Ricardo about the efficiency of our CPC. As you can see, 70 nanometer linearity at 99%, good R squared, characterizing the cutoff of 15 nanometers. The reason we chose 15 nanometers is to make sure that we're measuring some of the primary exhaust pollutants from vehicles at 23 nanometers where they're regulated, and any others that haven't been removed by volatile particle removers as well. Right, so this matrix here is an example of some of the cross interferences that can happen on these low-cost sensors. They're very flexible devices, but my favorite example always to give is with the NO2 sensors. So if we follow this along here, of course, for both indoor and outdoor air quality, this is a very important pollutant to measure. If we're thinking outdoor air quality and we follow this along to ozone, for every 10 ppm of NO2 we measure, you get previously a 5 ppm cross interference with ozone, which means you don't know which one you're measuring. And in urban environments, particularly in China, we're seeing an increase in ozone levels along with NO2 as well. It can become really difficult to actually characterize which one you're measuring. Fortunately, recently there's been an ozone filter added to these low-cost sensors, which means you can filter that out. This is where you need to actually be able to combine different sensor technologies to create a matrix to essentially add and subtract from each other to get good results. So these, I said, they're about £20. All of this information I'm happy to give anybody who wants to play around with these low-cost sensors themselves. They are extremely powerful but frustrating sometimes. And Carlos, please. These are the sort of sensors that we put in phones. Extremely small, measuring multiple components. Very low power consumption. Again, attractive ideas. You see lots of low-cost indoor air quality monitors in the market that are using these sorts of sensors to measure. And they're very good for indicative measurement, which is useful for if you want to know low or high, or even exceedance of an ambient air quality directive. And actually, for looking at things like behavioural change, which we're interested in, it's not always the best sort of device. Again, this is becoming a sensor. We develop sensors is what we do, so that's what we get excited about. But these low-cost CO2 sensors are actually non-dispersive infrared, standard method used in regulation, low cost, high accuracy. Again, I'm happy to share these slides if anybody wants to look in more detail on some of these different sensor technologies. So as I said, with these sensors, the first thing you have to do is actually make sure the number they report means anything. So this is where the metrology comes in, the science of measurement. So essentially what you do is you tell the gas sensor, whilst you're passing a flow through it of a calibration gas, right now you're measuring 1 ppm, 2 ppm, 3 ppm, and then you can correct this with an orthogonal calibration system. Also, you need to make sure there's a zero calibration. So this is just some example data of our CO sensors where we get a very good linearity. But of course, we see artifact responses from humidity and temperature, which can really conflate some of these data points. This is the exciting bit now. It's a small device, it's quite flexible. Some of the different applications that we've used this for. We've been getting quite a lot of press about some of our work on benchmarking vehicles for their comfort. So this is air quality, noise, vibration. Some of the work we're doing with Lancaster on indoor air quality. Citizen science, a big project we did in Belgium. Some of the work with Carlos and his team on occupational health and safety. And an exciting new project we have with mapping the air quality. So strapping equipment to the vehicle and driving around. So first off, this is our vehicle interior air quality. This is our trusty assistant, Justin, which is named by an intern of ours, which is to replicate human exposure to air pollution inside vehicles. So essentially what we do is install our equipment into a mannequin. It breathes through its mouth. This is our Terminator module here with a nice webcam at the top to see what sort of levels we're seeing in vehicles. But for us, we think that if you want to characterize what's happening in a car, you need to simultaneously know what's happening outside. which is why here, with a trusty suction cup, which we've tested at speeds of 100 miles an hour, it works just fine. Industrial grade, measures simultaneously inside and outside, because it's the ratio of these two things which is particularly exciting. So there's two key questions that we want to look at when talking about vehicle interior air quality. It's how much of outside comes in, and actually what's happening from this off-gassing of the new car smell from some of the vehicle interior components. So first off, we'll look at this first question, so if you can go through. This is some simple data from 4 vehicles. We have this on over 100 cars now, working with our client emissions analytics. And what this is looking at, blue is inside, orange outside. All of these, so this is 4 different cars, 1 car, 2 car, 3 car, 4 car. The left-hand column is recirculation mode off. So that's fresh air coming in from outside. And on the right-hand side, that's recirculation mode on, which we think of as aircon. And you press the button, it circulates the same air throughout the cabin. So what we're seeing here, this is for particle number averages over a 30-minute period, is with recirculation mode off, bringing air in from outside, we see much higher concentrations of particles. This is obvious. You put recirculation mode on, you see lower concentrations inside the car. If you can go to the next slide, please, Carlos. This is the same 4 cars. And if you can press again, what we're seeing is a big decrease in particles inside the cabin. What's important is there's different performances across the vehicle fleet here. This Japanese crossover, which I can't tell you what it is for legal reasons, is a SID. It's a 1-to-1 ratio of outside ultrafine particles, and this is over a 30-minute average. There are periods of time where there's actually much higher concentration inside. Whereas which is the cleanest car? This German sedan, around 25% of ambient particles getting in. But for all of the vehicles, we're seeing a very, very good increase in filtration efficiency when you move to recirculation mode on. And part of the reason that is, if you go to the next slide, please, Carlos, is these vehicles are built to be airtight, much like our buildings, our homes, everything like that. The principal reason for that is they want to be insulated against noise. This is one of the comfort metrics that we have on these cars. So the trade-off is when we move from a recirculation mode off to on, push the button please, is this stuffiness factor is CO2. So we're seeing a big increase in levels of CO2 in the car. The principal source is us breathing, so it's rather obvious. But the consequences of this can be quite dangerous actually for occupational health and safety for a truck driver. Again, this is 30 minutes with 1 person in the car. This index on the right, the left-hand side, is times background. So for example, with this German vehicle here, it's going to 5 times background, 2000 ppm. At these levels, we know it harms cognitive function, concentration. I don't know about you, when I'm driving, I like to be awake. Of course, with more than 1 person in the car, some of our experimental data shows over 30 minutes it can get to levels of 4,000 or 5,000 ppm. So some very, very high concentrations. This is the sort of information which the car manufacturers are beginning to switch on to, because working with the company emissions analytics, they're quite interesting in what they do. They're going to be aggregating all of this information into an independent labelling scheme on cars. This has recently just come into force in London for TfL for their independent emissions. So from the tailpipe, companies like Volkswagen have been a bit naughty. This is just to illustrate some of the areas where you can see these high concentrations inside cars, and there's often a bit of a disconnect in where we think this exposure could happen. So this is just driving from where we do our manufacturing in lovely rural South Wales over to London along the M4. So you look out the window left and right and you see green fields and you think I'm probably going to be in a reasonably clean environment. But driving at 70 miles an hour, you're effectively only be able to take news from the car, the boom of the car in front. So there's this beautiful Gaussian distribution over these arterial roads and motorways of pollution. So we can see some extremely high concentrations at these city bypasses where there's more stop-start, and we're seeing 100 times higher concentrations, getting up to around about 2 million, I believe that is. This always makes me laugh. This is a legitimate advert from one of Volkswagen's dealerships in the US from 2011, so before the Dieselgate scandal. but advertising their cars as having a new car smell. It doesn't like a new vehicle. But of course, we know in some of the higher temperatures, these VOCs spin off gas and be quite hazardous to health. So we did a little case study, again with emissions analytics, to look at actually not only in new cars, but older cars, what sort of VOCs are we seeing prevalent in the car. So the next 8 slides are just 8 different vehicles. So if you can just cycle through them slowly, regulatory new NEC are about to regulate this as another thing that the OEMs are interested in. And the experimental setup, again, back of our equipment, because we like the wet chemistry as well, space for 4 event-driven thermal absorption tubes. It's quite nice to get a TVOC value, but actually, what is a VOC? It doesn't mean anything without any speciation, which we'll get into in a moment. Then we ran this through GCMS with semi-quantitative analysis with some deuterium substituted hydrocarbons. So if you can go through, and one more slide. So this is 8 vehicles now, and if you can go through these slowly, what's important to see, these are the top compounds, is how different they're going to be in these vehicles. So if you can just press through slowly, Carlos, please. And keep going. And if you look at this bar chart on the left, keep going. We'll see these vehicles their lived-in experience is very different for some of these different compounds. And we have permission to say what they were, which is always nicer. Apart from this car. So the first thing we want to do is, well, say, well, actually, if we were just taking a TVOC analysis, what would we see? You can go one more through, please, Carlos. Well, apparently quite low concentrations. Only a few are marginally above the levels that we would see for irritation and discomfort. So you get that measure and think, well, okay, no problem. But actually, it's when we do the full GCMS analysis that the sexy and frightening data comes through. The Carlos, please, could you? So this is full speciation now. Of course, and these are the top compounds that are prevalent. Number 1, benzene. 3 micrograms cubic meter in this Fiat Punto. High concentration. Xylenes, some quite high concentrations again. You can see again, this Fiat Punto is a dirty car. Toluene, another carcinogen. If you go back a second. So all of these show that sometimes just getting this simple measure of what a VOC is isn't really that illuminating. And actually, getting this information, if it's packaged correctly, can really help the consumer make an informed choice, like it did me. This is my old car. All because of these results. I haven't tested my new car because I'm too scared, but so if we can move on to the next things, please. So our principal passion is indoor air quality. We set the company up to raise awareness of this because it's where the brunt of our exposure is happening. With increased urbanisation as well, of course, there's always this link inside-outside. So quite frankly, what we're polluting in an urban environment, air pollution doesn't stop at the front door, it's going to come in. Notwithstanding the massive sources we have of pollution inside. If anybody hears a smoke and smoking inside, please don't. It's awful. I've got lots of data to show you, but I'm not going to today. It's terrible. So why would we do this? What's the business model for it? Well, we would like to develop something similar to what we have as an energy efficiency audit on buildings, but for air quality. And the way we want to be able to do this is going through estate agents. So home buyers are already demanding ambient air quality data when they purchase a home as another index of a good neighbourhood along with crime or schools and public services. But actually we think it's a bit naive to make assumptions that what outside is going to mirror what's inside in certain areas. We know, for example, certain schools are installing quite sophisticated filtration systems in what would be polluted areas, and actually then inside can become quite clean. So we're developing a system to be able to, with an engineer, put equipment in domestic homes for a few days to benchmark air quality. So both from a buying perspective, if you're buying a home, you'd be able to get this information to benchmark to see against the national database where this home would sit for its air quality issues. But also from a selling, if you think you've got a particularly good filtration system and clean air, you can use another way to market your home. So we always like to give some, what you consider to be trivial examples of air quality issues inside a home. Here's a nice full English breakfast being cooked by one of our PhD students. And this is, across the day, 4 different cooking scenarios for ultrafine particles. And there's 2 things that are important here. First is the peak height, so the acute exposure. The second is actually the decay rate, and how long it takes into these different ventilation strategies. So it's going left to right. The first is with no ventilation, and we're seeing concentrations 1.5 million particles per cubic centimetre inside this home. So extremely high. And actually, we've measured upstairs and downstairs here just to see, well, actually, how are these particles moving within the home. So this is what's been done. But then when we look at the decay rate with no ventilation, cooking beginning at 8 AM, it's not until the middle of the day that it's even close to background, but it's still at 10,000 particles per cubic centimetre. What are the implications of this? Well, if that had been done at the end of the day, that was cooking dinner, and it takes 4 hours, and you're seeing high concentrations as well upstairs, up to 500,000, that could be the child's bedroom. So if we then move across to the right, and the second one is with the extractor fan on, again, we're still seeing quite high concentrations, because some of these extractor fans aren't as good as we think they are. There's a much quicker decay rate, even more so when we open a window for the third. And this fourth then, when we have the extractor fan arm and the windows open, the concentration is much less. So these are the sort of simple interventions that Joe Bloggs can take to mitigate their exposure to air pollution within a home. And if there's wide-scale general public knowledge on these small actions, the consequences on the National Health Service are huge. So there's other companies entering this sphere that we'll be working with soon to raise public awareness of some of the small things that can be done inside a home to minimise exposure. Those are some of the fun things we get to do. This is me with some students at a school in Belgium with my left-handed screwdriver, helping show them what actually an air quality monitoring device looks like to get some data. And so they measured out inside, outside at 13 schools. And what this is trying to prove is that anybody can use some quite complicated aerosol measurement technology. There's actual regulation coming in soon in certain countries of the EU, which will be mandating use of these CPCs for garage testings for MOTs. So the implications are then that an average garage technician needs to have some basic knowledge of aerosol science. So these sort of regulations are really pushing down both the capital cost of making this equipment, but actually making them much more turnkey and easy to use. And so the next slide, some very, very basic data which they presented, but they wanted to see, well, what's actually happening during school pickup and drop-off time? Are we seeing elevated concentrations? And this was a method which they wanted to put pressure on the parents to either walk to school, the kids, or to actually have designated drop-off areas which aren't directly outside the school gates. We're still seeing some peaks of up to 100,000 particles per cubic centimetre, high concentrations. This probably makes sense to most people here. This is work doing with Carlton Mayer on occupational health and safety, helping them using some of our device for nanomaterial measurement. So what we do with their box here is integrate our bench. So this is one thing we do, offer it as an OEM device for different applications. The right people to talk to about this project are in the room. I won't make any mistakes on your behalf. So integrating our bench. So this is our latest foray. This has come in directly again. We began indoor, and then a representation of indoor environments we realised in vehicle. And because we wanted to measure in vehicle, we thought we should measure inside, outside. We've been doing this for a few years indirectly, mapping air quality by measuring outside the vehicle whilst we're simultaneously measuring inside. And the implications of this are quite big. People like Google are already equipping their mapping vehicles with air quality sensors, with the hope of actually being able to increase the spatial resolution of air quality measurements in cities. So if we think of cities at the moment, they might have, in Lancaster's case, two air quality monitoring stations measuring different things. These 2 points aren't going to be representative of everything that's happening in the city. And actually any model that's then developed to reflect personal public health exposures to these pollutants isn't going to be very accurate. So the idea being is that you can combine this with mobile roving data coming from these stations to validate these air quality monitoring sites to increase the spatial resolution. So we had a bit of fun this summer just mapping the air quality in Lancaster to see, well, what's it like for ultrafine particle concentrations. So this is every evening for a week during rush hour. This is the city centre, and what you can see with this scale, concentrations go up to over 150,000 particles per cubic centimetre. But even driving at the same time, same route, these hotspots changed a lot. So for example, if we look at map B, down by the Water Witch, one of my favourite pubs, actually that road's quite bad during rush hour on this day. But other days it's not so bad. But we see some hotspots here, again down by the Water Witch, up more in map A in a residential area, and it becomes quite obvious that these are a function of traffic. So if we zoom in on some of these areas, so for example, again, this is this is down by the Three Mariners, and my geography in Lancaster is all based on where the pubs are. On one day, high pollution episode, on the second day, not so much. So the implications of this are in active traffic management and understanding that when we locate an air quality monitoring station in one site, believing it's a hotspot, these things change. So there's a second example, again, back down by the Water Witch, again, one day, high concentration, second, not so much. So hotspots change in space and time. That's what we need to understand when we're having a strategy for mapping and measuring air quality in cities. Which is why I'm excited to talk about our next project. So you can move forward a slide, please, Carlos. And one more. Where we've got a new Newton Fund project with Innovate UK to develop models to be able to predict air quality in cities. So we're doing this with the Chinese Academy of Science in Guangzhou in China. So China's third city, so it's an astronomically large population with 16 million, has some quite acute air quality problems. And they've set up quite a capital intensive network of 50 online monitoring stations, but still not seeing the improvements that they want. So by first developing a model with this already existing data to map air quality, you can then, at quite low cost, essentially strap a piece of equipment to a car to drive around and validate that model. And the implications of this will be very huge on actually how we plan our cities in terms of urban design, the advice we give to citizens on when it's best to go outside or exercise, or where we locate our schools. And so we're quite excited about this project. This is only a few weeks old, so we'll be presenting on this probably in the next 6 to 12 months. And that's just a few of the things we're doing. So thank you for listening, and happy to take any questions.